Good morning, students. Am I audible? So, only the last chapter is left out. That is our channel control and transitions. Here, basically, we are going to discuss about wires, then dam break problem, and subcritical and supercritical that we have already discussed. Okay. So here, basically, we have wires, then we have sluice gate. Okay. So basically, wires, sluice gate, and then we have dam break problem. Okay, so it's a very small chapter which is left out in your syllabus. Okay, so this we are discussing these things more or less related to your irrigation engineering with wires and all. So basically we have two structure, hydraulic structure. One is storage structure and one is diversion structure. Okay, so your wire is your diversion structure. So in when we construct wire, we are not going to store water. We are only going to divert the water from the main channel. Okay. So this is nothing but I have collected from NPTEL lectures, which is given by IIT Kharagpur. So you can go through to that and you can find some very good notes also related to your irrigation engineering. Okay, so those parts are related to irrigation engineering, so we are not going to discuss. We will directly go to the wires. Okay. Okay, so this is your first. Okay. Okay, so I think you have studied wires and notches in your third semester. Okay. Okay, we use sometimes wires. I think you have seen in the laboratory also. We use wire and notches to measure discharge in a particular channel. Okay, and sometimes we use to uplift the level of water so that we can divert the water for other purposes. Okay, so we'll discuss both the thing. Don't worry. But first, we discuss wire or notches. Okay, so this is nothing but we use to measure discharge in open channels. Okay. So wires are mainly divided into sharp and broad crusted wires. Okay. So wires are commonly incorporated in irrigation structures, and also it is not only used only for to determine the flow. Okay, it is also used to uplift the level of water and to divert that flow for other purposes, such like irrigation. Okay, if you have a river, we construct a wire and we raise the level of water and then we divert that flow of water for irrigation purpose. Then it's called we are using that wire for irrigation purpose. Okay, so we use wire not only for measuring the discharge, it can be used for other purpose also. Okay, so this is a sharp crested wire. Okay, so now see how this wire is, we can measure discharge. Because if you see, suppose this is a river, if you consider this is a river, consider this is a river, okay, and we know river is an irrigation, irregular shape, okay. So this is a river, and we know the cross section of the river is a irregular shape. Suppose in this way, okay. So now it is very difficult to find out the cross sectional area, because if you want to find out discharge, you have to find out area, cross sectional area multiplied by velocity, okay. So in small rivers, what we are going to do, we construct a weir or notches, okay, where the dimension through which the water is flowing is known to us, okay. The dimension of the wire, if you consider this is the dimension of the wire, okay, so this dimension is known to us, okay. So that irregular cross section we make as a particular shape. Suppose this is your, what do you say, it's a rectangular, okay. So before that we have a irregular shape, okay. After that we define the shape of the channel through which the water is flowing, that is your rectangular, okay. So now that to find out the cross sectional area, it becomes easy for us, okay, and then we can find out the velocity. Multiplying both, we can find out the distance. So for these wires we have a defined equation, okay. We have a defined equation. Suppose for sharp crusted wire, this is the equation for distance, okay, and those equations it's already derived, okay. So we can directly use that equation and we can find out the discharge, okay, for that particular channel. Before constructing the wire, it is very difficult to find out the discharge through that particular channel. After constructing the wire, we define the shape of the channel. Before it is an irregular shape, and after that we have defined the shape so that it is easy to find out the cross-sectional area as well as our discharge of the channel. So we can here the subtrusted wire we have directly, we have one equation which can be used directly to find out the discharge. So 1.84 L is the length of the, this is the length, this is the L part, okay, minus H is nothing but your head of water or level of water, whatever you want to say, okay. So H is the head in meters, okay. L is the length of crust in meters, so this is the L, okay, this L part. So this is how you can directly find out the discharge in a particular channel by constructing wire, okay. So wire also we have different types of wire, sharp crusted wire, broad crusted wire. So for each wire we have different equations to find out the discharge. So you can go through the diagram, and if you have any doubts you can ask me. Draw the structure, that cross section of the wire, and you write down the equation of that particular sharp crusted wire. Write down the equation of the sharp crusted wire, okay. Here this part also you have to write, where Q is the discharge in meter cube per second, L is the length of the crust in meters, H is the head in meters, okay. So you can write down this part, okay. over. Okay, so we move on to the next types of wire. Okay, so in the first case, our this wire is rectangular in shape. Okay, so sharp twisted rectangular wire. Okay, in the second case, we have a trapezoidal cross section. Okay, you can see that cross section of the wire or notches is trapezoidal in shape. Okay, this is the second. You draw a diagram. Okay, same. Okay, sharp twisted wire only, but the shape is different. In first case, your shape is rectangular, and this one is your trapezoidal. Shape is trapezoidal. Okay, so here your equation is also changed. Okay, as the shape of the channel has changed. This is nothing but the trapezoidal channel. Okay, trapezoidal wire, sharp twisted trapezoidal wire. Okay, it's also called this symplectic wire. Okay, so you draw the structure and then you write down the equation number 6 for sharp twisted wire for trapezoidal section. Okay, so we move on to the next. Okay, now it's a triangular shape. Okay, or you can say V knots wire. Okay, next one is your sharp only. we have V knots. The first one is rectangular, second is trapezoidal, third one is triangular, or you can say V knots. Okay, same thing. So it's a 90-degree V knots. Okay, so you can write down this equation, equation number 7. Okay, for V knots 90-degree. 8 by 15 twice G CD. CD is nothing but your coefficient of discharge. Okay, and what is coefficient of discharge? I think you people have already studied many times. Okay, so we are not going to discuss all these things again. Those things you have already studied in third or fourth semester. Okay, coefficient of discharge, coefficient of contraction, coefficient of velocity. So those things you have already studied. Even you have performed in the lab also. Okay, so we are not going to discuss all these things again. Okay, so you just directly write down the equation, that is 8 by 15 twice g cd to the power half h to the power 5 by 2. So this is the graph where you can see that coefficient of discharge is varying with h square by a, that is your head square divided by cross sectional area. Okay, so those things are related to your irrigation. Okay, the variation of CD for V knots. Okay, where with h square by a, that is your head square divided by cross sectional area. Okay, yeah. So these are the V knots. Oh, sorry, notches. Okay, sharp crested notches. Okay, so we are going to end this meeting and then we'll start again. Okay, and then we discuss about flume. Okay, so those things you have already discussed, so I have not discussed in details. Okay, you have studied in your second year all the wires, notches. You please go through your notes. Okay, whatever you have, or you can refer to a book also called RK Bansal, Fluid Mechanics and Hydraulic Machine. Okay, by RK Bansal, Fluid Mechanics by RK Bansal, or any book of hydraulics and hydraulic machine. Okay, so you can find all these things there. Okay, in a proper explanation with all the derivations. Okay. Okay, if you want to go through, if you forget the derivation and all, so you can refer that book, okay, for details. Okay, so we are going to end this meeting and then we can start another one. Okay, with next topic we are going to study about films. Okay.